All right, so welcome back. We are now number 5. And this talks about the discriminant. And if you remember back in class, we said the discriminant is the information underneath the square root. Expression under the square root. Okay, so I know I'm using this formula because it told us a quadratic equation. Well, the quadratic equation is that equation that y'all just love so dearly. B squared minus 4 times A times C, and that's all over 2 times A. Now we're only using this information right here because it's underneath the square root. A couple of things to remember, some rules. If B squared minus 4 times AC is greater than 0, you are going to have 2 solutions. If B squared minus 4 times AC equals 0, you're only going to have 1 solution. If B squared minus 4 times AC is less than 0, then it's no solution. This is probably something else that you would want to add to your notes. All right, let's go for it. Well, let's identify our A, our B, and our C. Well, our A is 4, our B is negative 20, and our C is 25. We're only looking underneath the square root. So B squared is negative 20 squared minus 4 times A is 4 times C, which is 25. Negative 20 squared, it's going to give me 400. 4 times 4 times 25 is going to get me 400. Well, 400 minus 400 is 0, which is 1 solution. Number 6. Solve t plus 7 to the power of 4 over 3 equals 2. So what we're going to do is get t by itself. That's my goal. So that means I need to unfold all of this. Well, right now, that denominator is 3. To get that from the denominator, then I'm going to put all of that to the power of 3, so that cancels out. The reason why I'm able to do that is because, let me do this really quick. If I take this chunk right here, I'm taking this chunk right here, and I'm going to bring it over to the side so you guys can see what's happening. So if I take this and bring it over here, that's like saying 4/3 times 3 over 1. Well, what's 4 times 3? 12. What's 3 times 1? 3. 12 divided by 3 is 4. We know that to be true. But I could do a shortcut. I see that this is a numerator and a denominator, and those can cancel out to still get me that 4. It works every time. Let's say I had 2/3 times 3 over 1. Those cancel out. I get 2. Well, let's check it. 2 times 3 is 6. 3 times 1 is 3. 6 divided by 3 is 2. All right. So if I know these are going to cancel out, that leaves me with the t plus 7 to the power of 4 equals 2. Remember, x squared is the opposite of the square root. X cubed is the opposite of cube root. X to the power of 4 is the opposite of 4 root. X to the power of 5 is the opposite of 5 root. And it can go on and on and on. So if I want to get rid of that 4, then I need to do 4 root. Whatever I do to one side, I have to do to the other side. I'm going to write over here to the side. Now I have t plus 7 equals 4 root 2. Okay. Then I want that t by itself. So I'm going to minus 7. T equals 4 root 2 minus 7. Pause the video because I know number 6 was kind of heavy. Okay. Let's move on. We just did 6. All right, we're on 7. So, number 7. This one is a lengthy one as well. My goal is to get W by itself. Well, I notice that I have a square root. 5W minus 4 equals 4. If I want to get rid of that square root, square. Now you're left with 5W minus 4 equals W squared. But I still want W by itself. So I'm going to move this over to this side. And remember, we do the opposite when we move things over. So now this becomes, went away, 0 equals W squared minus 5W plus 4. And I'm doing that because I wanted to say W equals blah. So now that I have this here, I can do my X puzzle. A equals 1. B equals negative 5. C equals 4. Excuse me. When I do the X puzzle, AC goes up here. B goes at the bottom. You're looking for two numbers that are going to multiply to get you 4, but also add to get you negative 5. I'm going to give you a moment to pause the video to figure that out really quick. Assuming that you pause the video, your number should have been negative 4 and negative 1. Negative 4 times negative 1 is going to get you positive 4. Negative 4 minus 1 is going to get you negative 5. Now that I have that information, we have W squared coming from here. We just broke up this negative 5W and got negative 4W minus 1W. And then we're going to bring up that positive 4. You should remember us doing something similar to this numerous of times now. What these have in common is W. There was 2 W's. You took out a W, you only got 1 W left. There's a W here. You took out that W, you only have 4 left. Here, I can take out a negative 1. I see a negative 1 there. I can take out negative 1. Well, if I divide by negative 1 here, I'm left with W. If I divide by negative 1 here, I'm left with negative 4. Oh, I have twins. That's what we like. That's what I want to see. If I don't get twins, that means I'm doing something wrong. My other binomial is W minus 1, and that's coming from your GCFs that you just took out in the front. Now we're going to set each one of these to equal 0, and you know how to solve these by now. These are easy. We like these. So W equals 4, and W also equals 1. Okay, come back for part 3.